Hello, we visited Providence Canyon on February 24th, 2018. This is a video of the geology of the canyon, but I have to do some background stuff first before I get into it. It was actually like 90 degrees that day, even though it was February. But what you see here is a stratigraphic column of the local stratigraphy. The basal cassetta sand is exposed in the park. However, we did not visit it. The Ripley was the lowest unit that we saw. Here are the descriptions. You can read those if you want. This is a time stratigraphic correlation here. The reds are unconformities. As you can see, the variable unconformity in the middle. In the park, it doesn't seem to be an actual unconformity. There does seem to be several feet of gradation to the above Providence sand. However, in other places, there is an unconformity. And here are the relative regional and local thicknesses. Now the canyon itself is a relatively new feature that was carved out in the past 120 years or so due to poor farming practices. Here are some facies we're going to visit and some geologic units we're going to visit in the video. Just wanted to show you how they relate to one another in the field. And these two photos are from 1938. They are when the canyon was really young. As you can see, there's not a lot of vegetation, and it has grown immensely in size since these photos were taken. But anyway, that is it, and let's get started.
Hey, we are in Providence Canyon, Georgia. It's about 12:17 on February 24th, 2018. GPS 32.06588 north, 84.91069 west. Now we're going to get into the epic stuff, but first this. This is the top of the Ripley Formation. It's Cretaceous. In some places there's an unconformity. This part is actually very fossiliferous outside of the canyon, but here there aren't any. You can tell it's the Ripley by the dark gray clays and organic matter, and the Providence is above. There is no unconformity here. This stuff is all upper Cretaceous. You can see it's kind of marly, sticky. It is technically sandy, but there is clay in it. So let's move on. Okay, it's about 12:55. We are still in Providence Canyon. We're off one of the gullies that comes up past where the last video was. GPS 32.06745 north, 84.90964 west. There's some things I wanted to talk about here. Sorry, out of breath, a little old. First thing, we'll talk about the geology, then we're going to talk about some geomorphology. You look up here, you can see the white sands of the Providence Canyons and a leaf falling. And as you can see, the manganese becomes more prominent, the purple up top, near the contact with that reddish-orange formation is the Clayton/Baker Hill. They're kind of interfingering here, so either or is correct. And it's an iron-stained sandstone and siltstone, but it has something interesting in it other than hematitic fossils. It has, and it's marine, or very near shore marine. There's some evidence of streams, and there is a contact between the white sands and the Clayton, and that is, here is the KPA boundary, the old KT boundary. But here, that iridium layer from the impact, even though we're not that far from it, you know, we're in Georgia here, it's not exposed here because there's an actual unconformity separating the Cretaceous from the Paleogene of about 2 million years. So that's not here. But what you have in the Clayton up there is you have white kaolin lenses, just white kaolinite clay. You can't really see them right here. They're more prevalent on the other side, but it was too hard of a hike. But if you look down, as you come down, you see the white sands, and you see this red here. Okay, this is a slump. This is the geomorph I was telling you about. This is just fallen sand and stuff. And sometimes you get these boulders. If you look over here, you get these. And the reason why these haven't broken apart like most of the sand is because there's kaolinite clay in here. As the stuff gets wet and sticky and then falls and fails, kind of balls it up, and then you get these big balls as big as this. You can see some of the white kaolin in right there at the base with the red, with the orange stuff. But we do have more purple manganese sand there But the Providence Canyon, the Upper Cretaceous unit here, the Providence Formation, is about, I think it's a couple 100 feet thick, but I just wanted to get some geomorph in here, and let's move on to the next site. We're just above where we just were. Here's some more purple manganese sand. What we have here is this yellow layer that's kind of lenticular. It's prominent here. That's the top of the Providence. There's the Clayton. You see it a little bit over there, but it's not to the extent it's sandier over there. Here it's mostly silt. This probably represents, it's cross-bedded, it has some manganese in it, but it's finer here. The overlying Providence tends to be coarse and angular grained, but this is probably a small lagoon deposit, kind of behind some sandy barrier islands. And here you can see the purple manganese and the some of the kaolin leaking down over the cliff during rain and coating it. But you can see it's you can see some sedimentary structures here. You can see some cross bedding. Now, almost everything here, generally on a massive scale, dips. It strikes almost east-west and dips almost due south, with some minor fluctuations to the slight west and east. But cross beds like these ones are dipping. It looks like kind of the northeast, but here you can see a flat bed, and you get planar cross beds here. It's sandier up here, so you go from a sandy environment. Now, even though these grains are coarse, they are quartz, and you go and you get some coarse in here, and then it becomes siltier. And this probably, like I said, represents a lagoon environment behind a barrier reef, or a bit, not barrier reef, barrier sandbar, which would have been to the south, and then your normal marine sands would have been to the north. Let's see what else we got here. Here's some more of that lagoonal, and as you can see, the lagoonal deposits, what makes this yellow, and I forgot to mention this, limonite. Now see here, you can see the cross beds are dipping towards the south, and then you got this layer that separates it. This is a cross bed as well. Then you see you have south dipping cross beds, and here this one dips towards the north a little bit, right there. And then you get back into south dipping cross beds, and then you get into flat lying deposits, and then you get more cross beds. This will probably be the final video actually in the canyon. There's Sarah taking pictures of the manganese layers. We are at, I don't know if you can see that, but 32.06717 north, 84.9087 west. You probably see it now. And we got a lot of purple manganese layers here in this canyon. This is all Providence sand pretty much right here. I remember 15 years ago, this thing was a lot taller, and it has subsequently wasted down, as you can see, coming through here. We have more manganese. Here you can see that little bit. Let me see if I can brighten it up. You can see the reddish orange. That's the Clayton right there, and it's stained the Providence a little, and this is all Providence sand, Providence sandstone. And that yellow lagoonal deposits I showed you at the last stop, they are even thicker over here. You can see them right there. Touch of Clayton on top. Here you can see the coarse white sand and the manganese. Unfortunately, it's not consolidated enough to keep. So we are still at Providence Canyon, and as you can see, I got sunburned. Sarah didn't, because she was smart and put sunscreen on. But there's the temperature now. Something I forgot to mention while we were down in the canyon is all these deposits are unconsolidated. They're soft. I mean, you can dig in them with your hands, even though they're 70 million years old. And the reason for that is because they were never deeply buried. So, as a matter of fact, if all the Earth's ice caps melted, the Gulf of Mexico would come up this far. We're that low in elevation. Trying to think if there was anything else I forgot to mention while I was down there.
Sand was pretty.
Yes, it was. Unconsolidated. I mentioned the Capon conformity. We got to see the 3 exposed formations in the park. I think that's it, but we're going to go along and I'm going to show you a couple more.